Here's a quick review of how we did implicit differentiation. That was section 2.5, and we talked about implicit differentiation. The necessity is when you have an equation that's written in implicit form. Implicit form means the x's and y's are kind of jumbled together. It's not explicitly solved for y where you have y equals and then everything else on the other side. When that happens, we have to go through and take the derivative using all the rules that we've learned, but also keep in mind that when you derive y, you get dy dx, because it's the derivative of y in terms of x's. So when you look at this problem, you see it automatically, it's implicit. We start taking the derivative. One thing that I want you to look for is look for product rules. You'll see right away that a product rule shows up at the very beginning of this one. Most problems that are implicit tend to have a product rule. It's kind of the AP's test. It's the way for them to write a test that tests if you can do the implicit and you can do product rule all in one problem. So we start this problem with the first times the derivative of the second. The second is y. The derivative of y is 1 dy dx. Plus the second, I'm going to leave myself a little room, times the derivative of the first. The derivative of the first is 4x. Because it's in terms of x already, we do not need a dy dx. Plus the derivative of 3x is 3. Again, because it's in terms of x, we don't need to do an adjustment. Minus the derivative of negative y is negative dy dx. Equals 0, because the derivative of a constant is 0. Once you've derived everything, now it's a matter of just doing the algebra to kind of shuffle things around. In the end, I want to isolate the dy dx. So the first thing I do is I'm going to take all the terms that don't have dy dx and move them to the other side by either addition or subtraction. In this case, they're both going to be subtracted to get to the other side, so you'll have a negative 4xy and a negative 3. You're just kind of regrouping, getting things with their like pieces, so dy dx pieces on one side, non-dy dx on the other. Next step is to factor out the dy dx from the side where you left it. So when I take a dy dx out, I'm left with 2x squared minus 1. This is the most common mistake, is forgetting that when you take it out of itself, you have to put a 1 there. And then the other side stays negative 4xy minus 3. And then your final step is to divide both sides by whatever is with the dy dx. This is your derivative. This is what dy dx equals. Expect that you end up with an implicit derivative, meaning you have a derivative that has the x's and the y's all jumbled up. If I asked you to find slope, I would have to give you an x and a y, unlike the other ones that weren't an implicit where all you needed for slope was to plug the x value in. If you notice here in the derivative, it has a y in it. And if it has a y in it, that means I need the y value and the x value to find slope. So there's an example of an implicit with a product rule, really the most common example. I want to do one more, just showing you the next level you can go with implicit differentiation. Here is an implicit equation, a little bit simpler than the last one. You'll notice there aren't any product rules in this one. What makes this problem more challenging is I'm asking for two things. I want the first and the second derivative. Second derivatives aren't as common with implicit, but they can be done. We'll go through this process. So first we're going to find the first derivative. Derivative of 3x squared is 6x. Derivative of y cubed is 3y squared dy dx. Derivative of 4 is 0. A little bit easier with the shuffling around because there's not many terms. I'm going to move the 6x to the other side by subtracting it. And then I don't have to do any factoring out because there's only one term left. I'm just going to divide by the 3y squared. This is my derivative. Now, it really is helpful when you have to do more with it to reduce it, to simplify it. So I'm going to write it as negative 2x over 3y, or over just y squared. I don't need the 3. That reduces. So no negative 2x over y squared. It does help to have it simplified. So that's the first derivative. Now the question wants you to go a step further and find the next derivative. So we are taking the derivative of this. When you look at that, the first thing hopefully you think is, I'm going to have to use a quotient rule because it's division, because we have two terms that are being divided. So when I start my second derivative, I'm going to come down here and do the second derivative. I'm going to do my quotient rule, so it's bottom times the derivative of the top, which is negative 2, minus the top times the derivative of the bottom. The derivative of y squared is 2y dy dx, all over the bottom squared, which is going to give me a y to the 4th. Now, when you go to clean this up, you have a couple things happening. First, I'm just going to work in the beginning here. That's a negative 2y squared. I'm also going to notice that the minus and a minus will cancel, and that I have a 2 times a 2, so it's going to give me 4xy. Here's the one piece of implicit differentiation when you're doing it twice that you have to remember. You don't want dy dx to still be as part of your answer. You need to have your derivative be in terms of just x's and y's. But we know what dy dx is. If you look right up above, this is what dy dx is. So where you see the dy dx in the second derivative, you need to replace it with what dy dx is, which is negative 2x over y squared. Now, I'm not going to ask you to do a ton of simplifying. One thing I would do is I would multiply the positive 4 and the negative 2. I would probably multiply x's and reduce y's, but I'm not going to get a big common denominator. So this is what I would be looking for a final answer. You have the negative 2y squared. A positive 4 and a negative 2 give me a negative 8. I have an x times an x, which is x squared. I have a y over a y squared, so you'll cancel this y with one of these, leaving you with just a y in the bottom. And it will all be over y to the fourth. Now you could go a lot further with simplifying. You could multiply by the reciprocal. You could get common denominators. I would never ask you to go those lengths. I've seen problems with second derivatives on AP tests. They don't ask you to go that far. Really, once you get the derivative and you replace dy dx, you're usually at a place where you could stop. Or they might give you a point. They might say, well, what if the point 1, 1 is on your graph? What would the derivative be? What would the second derivative be? Once you have everything subbed in, you're ready to plug that in. You don't need to worry about oversimplifying. So here is perfectly acceptable answer for second derivative, and a pretty challenging problem because it makes you go through the process twice.